Okay. Okay, welcome back again, or welcome into the live lesson, guys. This is your Maths Gamer host. We are actually jumping in, guys, to look at a important topic here that we actually are referring to as probability. We are here to look at probability, the probability. Okay. So just to first start this thing for grade 8s and 9s, because grade 8s and 9s, unfortunately, depending on the situation in your schools, you either do this topic or you don't. And honestly speaking, in the syllabus for the past few years, this has been a topic that has been not covered at all, right? And it's just something that I've just felt like I need to at least do so that people do get the exposure, and then they know about it and they know how to do it. So I'm going to do probability, all right? And let's jump right into it. What is probability? The definition for probability. Probability, guys, is the likelihood or the chance that something might happen. I repeat, probability is the likelihood or the chance that something might happen. Okay, so you'll oftentimes have people saying the chances of this happening, or the likelihood that this will happen. All right, and so basically that gives us a sort of like we are saying, for instance, what are the chances? For instance, today, and I know in some places in the country it's raining, all right? And maybe someone could have woken up this morning and been like, or let me say yesterday, could have said, what are the chances that it will rain tomorrow? All right, so that's why you have what we call weather predictions, okay? Weather predictions, right? And those basically are also supposed to give us an idea as to the chances of something happening. So when we look at probability, guys, there is what we call a probability, and I'll call it a scale, right? A probability what? A probability scale. From 0 to 1. That's if we are looking at whole numbers. All right? Or we could say whole numbers where we have a rational numbers in the mix. Okay. Now, in the scale of probability, the question is, if you're saying 0, there's a 0. There's 0. Okay. That can be equated as far as percentage is concerned as 0%. Okay. 0%. In the world of probability, 1 would mean 100%. Okay. So what do we mean by 0? It means there's no chance. Impossible. Not going to happen. Okay. Impossible. So no chance, impossible, not going to happen. Okay. What are the chances that you will fall pregnant as a grade 9 learner? Guys, I would really hope that you are saying 0% chance. What are the chances? Let's say you're not drinking as of yet. Haibo, Lindeland, 1. What do you mean? Hey, what is this guy saying? What are the chances that you'll fall pregnant? And you're saying 1. What is this? So you're meaning, hey, Mihlola. What is this, Lindeland? Hi. These kids nowadays, what's wrong with you? Hey, but you know, the thing is, guys, you my 2Ks and people like this, the reality that you are living in, I wouldn't be surprised, you know, maybe Lindelani is speaking his truth and he's not joking, you know. He is not joking. He is like 100% being honest, you know, because that's the thing about Matuke. Matuke are very honest, you know, they are very bold. They can stand for something, whether it's right or wrong. But yeah, guys, we need a generation of young people that can actually stand for something that is good and right. Okay, maybe your boldness and your ability to speak out is something that is needed in our generation and age, because we need more people that can stand for what is right. They can stand for integrity, they can stand for honesty, they can stand for purity, you know. It needs to be the in thing, because nowadays it's the out thing. It needs to be the in thing, you know, for you to say, I don't drink, I don't smoke, I don't sleep around. It needs to be the in thing that you don't do these things. But hey, today it's the in thing that you are doing these things. So hey, hi. But anyways, so 0%, 0 means no chance, impossible, not going to happen, not going to happen. 100% chances means certain, for sure, going, happening, no doubt. Okay, all right. Now, midway between these two, we have half, 50%, or you could say 0.5. All right. This means it's equally likely that it could happen, or it's equally likely that it could not happen. It's like 50-50. You know what the people say, 50-50, right? Now, the more towards this side we are, then it means it's less likely. But the more towards we are this side, then it means it's more likely. Right? Okay, does that make sense? It's more likely. Because probability is between 0 and 1. That's the scale that we measure probability. Probability of a particular event. This E just means of a particular event. Is between 0 and 1. Right? So as I said, for whole numbers and rational numbers, it's between 0 and 1. Okay? 0 and 1. It's not greater than 1. It can never be less than 0. It's either 0 or in between or 1. And as I said, 0, when the probability is 0, if you calculate probability and you say it's 0, then it means There's no chance of that thing happening. It's impossible. It's not going to happen. Then between 0.5, if the value is between 0.5, in other words 0 and 0.5, or percentage wise between 0% and 50%, right, then it means that that particular thing is less likely to happen. Okay, the more towards 0 it is, it means it's less likely to happen, right? So that's why if it's between 0.5, we say it's less likely. But if it's between 0.5 and 1, then it's more likely, right? Are we together? It's more likely to happen, right? But if it's exactly, then it means it's equally likely to happen, right? And then of course 1 or 100% means it's certain for sure it's going to happen. All right, so our scale, guys, okay, is between 0 and 1. Okay, so when we calculate probability, we are operating within 0 to 1. So probability can be greater than or equal to 0, but less than or equal to 1. This is important for you to note, guys. Very, very important. Can be converted to a percentage, obviously. These values can be converted to a percentage, right? Or we can write them in decimals. Okay. So we can write them in numbers, we can write them as a decimal, we can write them as a percentage. So that's important. Probability can be written as a number, decimal, or percentage. Okay. All right. So this here, guys, is the general definition. Probability generally is the likelihood or the chance that something happens, right? There is a scale. There's a scale to probability, because if we are going to measure the likelihood or the chance of something happening, we must know that there's a scale, right? From 0, as I said, to what? To 1. At 0 exactly, okay, as a number. Decimal, we can say 0 as well. Percentage, we say 0%. When we have that as our probability, we know that there's no chance that will happen. It's impossible. It's not going to happen. That's what 0, 0 or 0% means. Midway between 0 and 1, we have half. As a fraction, we have half. As a decimal, we have 0.5. As a percentage, we have 50%. Okay, and basically what does that mean? It means it's equally likely that something may happen. It may not happen, or it may happen. There are 50-50. There's 50-50 chances of that being the result. Then at 100%, or we say 1, when the probability is 1, or we say percentage-wise it is 100%, then it means for certain, it's going to happen, this thing. It's happening, all right? Happening for sure. We are certain. It's certainly going to happen, okay? Then if we are in between 0.5 and 1, more likely to happen. But if we are between 0 and 0.5, less likely that that particular thing will happen. So this is the scale, guys, of probability. Can be between 0 and 1, okay, represented either as a number or a fraction, decimal or a percentage. Probability can be represented in one of these ways, okay, right? Formally, probability of an event is the number of favorable outcomes over the total number of possible outcomes. This is the formal definition of probability of an event. In other words, probability of an event. That's the notation. Probability of an event is equal to what? The number of favorable outcomes in that event over what? The total number of possible outcomes. Okay, so this is the formal definition of probability for the purpose of calculations. Okay, the number of favorable outcomes in that event over the total number of possible outcomes. That is the probability of an event. So for the purpose of calculations, we use this beautiful definition there that you can see. Okay, so far that's what I have, guys, so far. Right, I hope we are following along. Okay, guys, the scale of probability is just between 0 and 1. Just 0 and 1, please. Okay, so for numbers, 0 and 1. If we are looking at percentage, 0% to 100%. If you are looking at decimals, obviously, and if you're looking at fractions, you can represent, obviously, probability as a fraction, because if you have the number of favorable outcomes over the total number, then you are going to have a fraction. That fraction you can convert to a decimal by simply pressing SD in your calculator after punching in the values, or you can represent it as a percentage by simply multiplying by 100 when you have the fraction, or multiplying the decimal by 100. Okay, so you can always represent probability either as a what? As a number, or a fraction, decimal number, or a percentage. Okay, all right, and then you can interpret, you know, what they mean in a particular event depending on your probability. That thing, there's no chance of it happening, or that thing, there's equal chances, or the more it is towards between 0 and half, it means it's less likely to happen, or if it's between half and 1, it's more likely to happen. Okay, and the more closer it is to 1, it means the more and more likely it is to happen. Okay, but the more closer it is to 0, it means the less and less likely it is to happen. So you can gauge the strength of the probability depending on the value. All right, for instance, what are the chances that you guys, all of you in this live lesson, will get 90% and above for mathematics for all 4 terms next year? What is the likelihood that you will get 90% and above for all 4 terms in mathematics next year? Well, that is a question I'd like to ask the grade 8s and 9s. What is the chances that you will get 90% and above for mathematics all 4 terms next year? Comfy is like 100%, long lasting is like 1. Yeah, you see, the thing is, that's very important, because if you are saying that, then you are saying for sure there's no ways that won't happen. Amila is like, there's a bit of doubt, because Amila is like, there's chances that it might, but there's also chances that it might not happen. I might just fall short of 90 and get 89. You see, so there's that room. All right, so how then maybe can we strengthen our resolve, or strengthen the probability being more towards this? Maybe when we are part of my early preparation classes, you guys are going to begin to see that, oh wow, this guy is making the maths easy. And then as you become part of my WhatsApp group and as you get direct support from me, then maybe you are going to say, oh man, this guy is really helping me out a lot, despite the fact that my teacher may be there or not. It's supporting me, this man. And by the time you start next year, maybe you'll be speaking a different language when you start your academic year next year, when you see how much it is that you have learned by that time, because you've been part of my early preparation for mathematics classes. So please guys, if you are wanting to be part of that, when we start on the 13th, you need to contact me on the side and send me a message so that I can give you the information and the details with regards to it. This is not going to be something that's going to apply for everyone. It will only apply for those that actually make the payments there. Okay, it's very key guys, so please let me know so we can increase the probability. Can see some people already know. They're like, aye, for sure. Aye, which is very good. Hopefully you are not just romanticizing and saying things just for the sake of saying them so that you can make us feel good here, but you actually really mean it, and you have the academic evidence to support, and also you are going to be showcasing your academic performance throughout the year next year. Okay, anyways, let's move on. Now there are two things I want to look at, and that is the word frequency. Frequency of an outcome is the number of times an outcome is obtained. Sorry guys about that. Frequency of an outcome is the number of times an outcome is obtained. Repeat. Frequency of an outcome is the number of times an outcome is obtained. That's what the frequency of an outcome is. Frequency of an outcome is the number of times an outcome is obtained. When an experiment is repeated. All right. So then we have something that we call the relative frequency. Right? The relative frequency, which sometimes we are required to calculate, or sometimes another word for it is what they call the experimental probability. So we have the formal definition of probability, which I've just exposed you to, which is the probability of an event is equal to the number of favorable outcomes over the total number of possible outcomes. So that is the formal definition, and we use it for calculations. Sometimes they don't ask us for the probability of an event, but they ask us for the relative frequency or the experimental probability. Okay, I just want to use another word as well here, that the formal definition is called the theoretical probability. See, now I'm exposing you to some terminology. This terminology, I'm exposing it to you now so that when you go to grade 10, when you see it again, you are not shocked. So the formal definition of probability is usually called the theoretical. Theory is something that we read, all right? So the theoretical, it's like the definition of probability, the formal definition of probability. The probability of an event is equal to the number of favorable outcomes over the total number of possible outcomes. For the purpose of calculations, we use this theoretical probability definition. Then we have something called relative frequency, which is formally known as experimental probability, because it has to do with the frequency. These are the keywords. The frequency of an outcome is the number of times an outcome is obtained when an experiment is repeated. Hence, we are saying experimental probability, which is also called the relative frequency. So these are terms you need to know because we use them interchangeably. We can say relative frequency when we mean experimental probability. We can say experimental probability when we mean relative frequency. So the formal definition is the number of favorable outcomes. Nearly like what the formal definition says for probability. The number of favorable outcomes during the experiment. The number of what? Of favorable outcomes in the experiment over the number of times of the trial of the experiment. Okay, so I'm going to look at examples so that you guys can understand what this all means. Okay, both for theoretical probability and for the experimental one, I'm going to look at examples. Okay, so let's look at an example just for the theoretical probability first. Example 1 for theoretical probability. I love these people that keep on saying it December. These people that keep on saying it December are liars, because guys, it's not December yet, it is actually November. So they are lying. The Mahotse people are lying to us. Example 1 for theoretical probability. So let's say, what is the probability of rolling a 3 on a die? Do you all know what a die is, guys? Or what you refer to as sometimes a dice, a die or a dice, okay? Because remember, die means one, singular. Dice is plural for many, okay? Can I say die or dice? Okay, so what is the probability of rolling a 3 on a die? Okay, what is the probability? Now remember, guys, if they are asking for the probability, they are, in other words, asking us for the what? The theoretical probability, whose definition we know. Okay, so if they ask you for the probability, then it's like they're asking you for the what? The theoretical one. So what do we say? We first say PE, the probability of that particular event, is equal to the number of favorable outcomes over the number of total possible outcomes. So let's look at a die. Okay, a die, guys, a die has 6 total possible outcomes. Okay, I hope we know that. A die has a 1, a 2, a 3, a 4, a 5, and a 6. Do we all know that, guys? One die, a die or a dice, has 1, 2, 3, 4, 5, and 6. The 1 is represented by that dot in the die. The 2, this one. The 3, this one. The 4, that one. The 5, that one. And then the 6, the one that people love a lot, is represented by that one. Do we all know what I'm speaking about here, guys? So these are the possible outcomes that are there. There's a 1, there's a 2, there's a 3, there's a 4, there's a 5, and there's a 6. So my total possible outcomes, the number, this N means number. The number, now there's another word that we usually use in probability called the sample space. Yeah, I long do. Iyafana kuda uMamsondo le uMamsondo iyafana ngathi ndilaxaza ndilahla ngaphandle. Okay, anyways. sorry guys about that. Someone was trying to call me now. I'm like kind of struggling there. So the number of total possible outcomes. Do we all understand this, guys? Okay, the question was saying, what is the probability of rolling a 3, right, on a die? So when we think about this, we're like, okay, they were asking us the probability. So what do we need to find out? We first need to find out how many total possible outcomes are there on a die. If I was to roll a die, my die can either land on 1, could land on 2, could land on 3, could land on 4, could land on 5, could land on 6. So in total, in my sample space, because the sample space represents all the outcomes, all the total outcomes. Okay. On a die, there are 6 total possible outcomes. There's 1, 2, 3, 4, 5, and 6 that are possible. So when I say number of total possible outcomes, I'm thinking of possibly 6 of them. Okay. Then that will accommodate my denominator. I know what's going to be in my denominator. Number of favorable outcomes. They are saying what? What is the probability of rolling a what? A 3. How many 3s do I have in a die? How many 3s do I have in a die? I only have 1. So that means 1. Right? So when I go now to my definition, I'm saying the probability of the actual event is getting 3. So I say the probability of getting 3. 3 is my event. Then what are the number of favorable outcomes if I'm talking about the event 3? And then what are the number of values in my entire die? There's 1, 2, 3, 4, 5, and 6. So in total, I have how many? I have 6. Okay. Right. So all in all, I can say the probability of getting a 3 is equal to the number of 3s. Now, how many 3s do I have? I only have 1. Over the number of total possible outcomes. How many outcomes in total do I have if I'm talking about a single die? There are 1, 2, 3, 4, 5, 6. I already explained to you that the number of possible outcomes, total possible outcomes, is 6. So I'm going to then say 1 over 6. And so this 1 over 6 is the answer. If I wanted to represent this as a decimal, then I can represent it as a decimal, right? By saying 1 divided by 6. And that 1 divided by 6 will give you what? You can check for yourself, and then you can verify for me in the comment section what that 1 divided by 6 gives you. Then if you want to represent the answer as a percentage, you take that 1 over 6, you times it by 100, and you get what? You can tell me in the comment section what you get for your percentage answer as well. Okay. And these would be 3 different ways of representing the same thing, the probability of getting 3. As a fraction, it's 1 over 6. As a decimal, you can tell me in the comment section what you get. And as a percentage, you take that 1 over 6, guys, you times it by 100%. You will get the percentage, all right, which is also the probability of getting 3. Okay, so the probability of getting 3 is the number of 3s over the number of total possible outcomes I have when dealing with a die. Right? Because the question was, what is the probability of rolling a 3? So the favorable outcome is getting a 3. How many do I have? 1 3. over the what? The total possible outcomes. How many outcomes do I have in a die? There are 1, 2, 3, 4, 5, 6. So the number of total possible outcomes is 6. So then when I get the probability of that event, which is 3, it means the number of 3's, which is 1, over the number of total possible outcomes, which is 6. Then that 1 over 6 is my answer. It's the fraction that I get. If I want to represent it as a decimal, you can say 1 divided by 6. You will get the answer there. You can tell me what the answer you get as a decimal is. Then if you want to convert that same fraction to a percentage, you take that, you times it by 100, you get the percentage answer as well. So depending on how they want the answer to be, whether they want a fraction or they want a decimal or they want a percentage, you are in the position to convert your answer to any one of these three, and then you can actually present the answer the way that they want the answer from you. Okay, I hope that makes sense, and I hope you can make sense of it. I'm still just waiting for you guys to tell me what's 1 divided by 6. If you press SD in your calculator, what do you get as a decimal number, rounded off to 2 decimal places? And then if you take that same 1 over 6 and you times it by 100, what do you get for your answer as a percentage? If you guys can just confirm that for me in the comment section, I really appreciate it. And then I can move on to the next concept of experimental probability. You can look at an example of experimental probability. Okay guys, I see we are not really commenting there. So if I was to write down the answer, 0.17, if I round off to 2 decimal places, it's 0.166666, the repetition of 6. So if you're going to round off to 2 decimal places, then it's going to be 0.17. This here is a percentage. You times that by 100. Okay. If you times the 1 divided by 6, you times that by 100, you get 16,67. So if I round off to 2 decimal places, it will be 16,67%. Okay. All right, I hope you guys get this. Very, very important. Okay, if we were rounding off to 2 decimal places. Okay, I'm going to do one last thing with you guys for today. As I said, this is just part 1 of the probability for grade 8s and 9s. I don't want to do too much on one day, just want to do a little bit, and then at least give you the wings to fly. So let's look at an example that has to do with experimental probability. Okay, and as I said, experimental probability is also referred to as relative frequency. So let's say a die is rolled 50 times and a 3 out of those 50 times is scored 9 times. So then the question is, what is... No, I'll give you some problems to do. Don't worry. What is the relative frequency, or what is the experimental probability of getting a 3? No, I'll give you some practice problems for probability, don't worry, so that you can see this thing. Okay, so then example 2 here. the die is rolled 50 times and a 3 is scored 9 times. Now the question is, what is the relative frequency of getting or scoring a 3? Okay. Does that make sense? So we are told here a die is rolled how many times? 50. And then a 3 from the die is only scored how many times? 9 times. The question is, what is the relative frequency of getting a 3? So now we are being asked the relative frequency. We are not being asked the probability or the theoretical probability. We are being asked the relative frequency. Now, if we go then to the definition of relative frequency, we said that the relative frequency or the experimental probability is the number of favorable outcomes in the experiment. Okay? The number of favorable outcomes in the experiment over the number of times of the trial of the experiment. So then we can say here, if we look at this example here, we are told that the die is rolled how many times? 50, right? So here we have the number of times the experiment was done. It was done how many times? 50 times. Okay. And how many times did we score the 3? We scored the 3 9 times. We got 3 9 times out of the 50 times. So 9 out of 50. Does that make sense? The total number of times we rolled the dice was 50, but we scored 3 out of the 50 times only 9 times. So if we want the relative frequency, okay, that will be equal to 9 over 50. Okay, 9 times that we scored the 3 out of 50, because we want the relative frequency of getting a 3. Okay, so that is 9 times out of the 50 times. Okay. Then from there, we can basically either simplify, if it is possible for us to simplify. Let's say they wanted the answer as a decimal, then it's a matter of actually saying 9 divided by 50. Okay, and what do we get with 9 divided by 50 if we press ST? Exactly, Amila, we get 0.18. So if they wanted the answer as a decimal, it's 0.18. If they wanted the answer as a percentage, let's say they wanted the answer as a percentage, then we were going to take this 9 over 50, times it by 100, and then we were going to get the percentage. And I'm sure you can see what you get when you multiply 0.18 by 100, you get 18%. Okay, does that make sense? So that would be the relative frequency of scoring a 3. Okay. So guys, relative frequency, all right, is literally, as I am saying, relative frequency is the number of favorable outcomes. We are looking at 3 specifically. That is the outcome we are favoring over the others. We are favoring this outcome over 1, 2, 4, 5, and 6. We are specifically looking at 3. That is what we call our favorable outcome. All right. So the 3 is scored how many times? 9 times. Therefore, at the top, I am writing the number of favorable outcomes in the experiment. Right. And that 3, I was able to get 9 times. So that's what I write at the top. The number of times that favored option came about. divided by what? The number of times of the trial of the experiment as a whole. So I rolled the die 50 times over 50. So that's why it's 9 divided by 50. If I want to write the answer as a decimal, I can press SD in my calculator and get 0.18. If they want the answer as a percentage, I take that 9 divided by 50, I times it by 100, I get a percentage, 18%. So guys, what have you observed? When I calculated this probability, I got an answer between 0 and 1, 0.17. If you look at the probability scale, 0.17 is below 0.5. It's more towards 0, which means the chances of getting a 3 from a die is actually less likely to happen, right? There's 1 out of 6 chances of getting a 3 on a die, right? So this is how you would then obviously interpret it in words. The answer you had got for your probability was between 0 and 1, as you can clearly see. And if you converted your answer to a percentage, you got 16.67%. That is a percentage less than 50, which is falling in this region. All right, I hope that makes sense. So it's less likely to get a 3 from a die. Then if you move right along and you check out the experimental probability, our definition of experimental probability, guys, informs why it is that we get 9 at the top and 50 at the bottom. Okay, and then obviously our conversion to decimal, 0.18 to percentage, it's 18%. Now, this thing of theoretical probability versus experimental, okay, it's like the more we repeat an experiment, the closer it becomes like the value for our theoretical probability. The more, I repeat, the more we repeat an experiment, the more we do what? We repeat an experiment, the closer it becomes like the value for our theoretical probability. Let me just show you something here, guys. If you look at, we were talking about rolling here a 3 for our theoretical probability. When we got the value for the probability of getting a 3, we got 0.17. Right? When we experimented with the 3 and we rolled our die 50 times, we got 9 out of the 50 times. And the value that we got was 0.18. If you look at 0.18 and compare it to 0.17, these are values that are very close to each other. And what I have just said to you is that if we continue to roll this die more times than 50, then I can tell you, you see this value 0.18, it will get closer and closer to this 0.17, which is the theoretical probability of getting 3. So the theoretical probability of getting 3 opposed to the experimental probability, this value of the experimental becomes closer and closer to the theoretical probability value the more we extend the number of times this experiment is done. But the less times we do so, then that value is not as close to that one. That is just what this thing is saying. The more we repeat an experiment, the closer it becomes like the theoretical probability value. And that is just something to know for yourself, because experimental and theoretical probability are important concepts when it comes to probability. Okay. So I think we are going to hold it right there for the theory of what we mean by probability. And then let me give you a chance to look at some problems. And to do that, I'm actually going to specifically let's look at a few problems that you guys can do, and let's see if you guys can do them. A coin is tossed. And I repeat, a fair coin is tossed. What is the probability of getting ahead? I hope you guys know that a coin has, a fair coin at least, has two sides to it, right? So the question is, a fair coin is tossed. What is the probability of getting ahead? The theoretical probability would mean that of getting ahead. Maybe you guys would be able to tell me without even having to really do this. A fair coin is tossed. What is the probability of getting ahead? Okay. So we go back again to that definition of probability. Probability is the numerator, number of favorable outcomes. So what is our favored outcome here? What are we wanting to get? We're wanting to get a what? A head. That is our favored outcome. How many heads do you have in a coin? You see, these are the things you must ask yourself. All right. Then, for your denominator value, what are you going to say? Denominator, the number of total possible outcomes. So the question is, how many possible outcomes in total do you have on a coin? Then after you have done that, you then write down, right? You then write down the answer. Okay. So I'm just going to give you an additional minute to write down. I see your answer there, Tabisa. Thank you so much. I love that you went ahead and wrote your answer, but I see the question marks. I don't know if the question marks are indicating that you are not so sure about what you wrote down. What does everybody else have to say? The probability of getting ahead. It's nice when the learners participate here and I can see that, oh, okay, the learner understands. Oh, no, the learner is lost. Oh, no, the learner needs more. Okay, we see a half as well from my, with some weeping facing the malume. Then don't know. It's crying there. Don't know why it's crying. A fair coin is tossed. What is the probability of getting ahead? In the word amila, what is the probability of selecting the letter A? In the word AMILHA, what is the probability of selecting the letter A? That's another question for you guys. In the word amila, what is the probability of selecting the letter A? Then B, the probability of selecting the letter M. Okay, 2 questions. Okay, just trying to get you guys a bag contains 10 marbles, 5 red, 3 green, and the rest are yellow. If you pick a marble, what is the probability that it will be A, yellow, B, red, C, green, D, purple? A bag contains 10 marbles, 5 red, 3 green, the rest are yellow. If you pick a marble, what is the probability that it will be A, yellow, then B, red, then C, green, then D, purple? Okay. So hopefully, as you guys are seeing these questions, it's making you be able to think so that you can do them and answer them. All right. I'm just going to give you some time to actually go over there. Yeah. And you can answer them. Guys, I think I'm going to end right here. All right. So that you guys can do these. All right. Please, if you do finish, please take a screenshot. Do finish, you can send me in an inbox there on TikTok when you have finished doing a particular problem. All right. Like I said, I'll see if I can't go live again later on today or in a few hours. All right. Even if in a few minutes. I just have to have breakfast now. I need to have breakfast now and have to do a few things here in the house. But yeah, let's do that. All right. If you guys can screenshot, I'd really appreciate it so that you can have the problems to do for yourself. 5 seconds, I'll give you guys to screenshot. 5, 4, 3, 2, 1. Hopefully you've screenshotted. Okay. And then additionally, for relative frequency purpose, screenshot this one too. Okay. For screenshot 1.1. All right. In fact, this up until 1.4. Okay. 5, 4, 3, 2, 1. I repeat, 5, 4, 3, 2, 1. Just this here. Okay. Right. Guys, let me love and leave you. Thank you so much. It was really good.